creating an AC to DC power supply circuit using LT-SPICE simulation software. So as you can see here, the interface is a bit different. Well, that's because I am using a Mac OS and not Windows. So later on, I might be mentioning a different command, but it's okay. It works exactly the same as the one we are using before because it's the same LT-SPICE software. So anyway, let us start with the components. The first component is the voltage for the AC supply. Let's place the voltage here. So let us set its function to sine with the DC offset of 0, amplitude of 220 because that's our AC voltage, and frequency of 60 Hz. So next, we will be needing two resistors. So let's place the first resistor here and the second resistor here. Let us name this resistor as RW because it will serve as the primary winding resistance. Well, for us to be able to run the simulation, we need a small resistance that is in series with the primary winding. So that's why we will give RW a value of 0.01. And for the R2, we will name it as R load with a value of 1000. So next, we need two inductors. So these two inductors will serve as the primary and the secondary inductances of a transformer, since LT-SPICE does not have an option wherein we can enter turns ratio. So let us give L1 a value of 1600 microhenry and L2 with 6.5 microhenry. Okay, so now we will be needing 4 diodes that will comprise the bridge rectifier. So we need the 1N914 diode. So this is because bridge rectifiers can give higher RMS voltage and it can use a small filter capacitor. Okay. So let's pick 1N914, which is silicon type. This goes to all of the diodes. Diode. Okay, let's just move it here. Okay. And as I mentioned, the bridge rectifier can give us small capacitor. We can make use of small capacitor. So let us get capacitor and place it here. So let's give this a value of 500 microfarad. So there. Let us now connect everything with the wire. So Fn plus F3. Next. We just cut this. Okay. Okay, and lastly, to finish all this, we need ground. We'll just have to click G and this will come out. So again, let's connect it with wire. Of course, we need a transformer declaration here. Let's go to the SPICE directive and we can just simply type K1, L1, L2, and 1. So K1 here is the declaration number. L1 and L2 are the inductances, and 1 is the constant, which is the coupling coefficient. So we can just place it here. And of course, for us to be able to run this simulation, we need a transient simulation command. So let's go again to the SPICE directive. We can just simply type it here, but let me show you using the analysis command. So for the stop time, let's type 100M, and let's check start external supply voltages at 0 volts. Okay, you can place it anywhere here. So lastly, let's just put label net here. So this is V in. This is the secondary V sec. And this is V out. Let us now run the simulation circuit. Okay, so here it is. So our AC voltage is 220, so let's check it. And our desired voltage for DC is 12. So let us check it here. So there you have it. So this is the voltage in, and this is the output, which is 12. So that's all for my project.